Hello students, welcome to the chapter Coordination Compounds. Let us continue our discussion with the ligands. But now this time we have a different category of ligands which are called as ambidentate ligands. Let us understand what exactly is meant by ambidentate ligands. To understand this, here I have a ligand which is NO2 minus. In this case, we have two donor atoms. One is the nitrogen. So if you see here, nitrogen is involved in the formation of a coordinate bond. Whenever the nitrogen is acting as a donor atom, it is called as nitro N. But in the same ligand, even oxygen can act as a lone pair donor. So in the same, even oxygen is participating in the formation of a coordinate bond. Whenever oxygen participates, we call it nitrito O. So if you see here, it is a single ligand, but it has two donor groups. Always remember, at a time only one will participate in the formation of a coordinate bond. Such ligands are called as ambidentate ligands. Let us understand this with the help of few more examples. Ambidentate ligand, again, SCN. In SCN, we again have two donor atoms. One is sulfur. So when sulfur is forming a coordinate bond with a metal, it is called as thiocyaneto. In the same ligand, even nitrogen can act as a lone pair donor. So in this case, nitrogen is forming the coordinate bond. So whenever sulfur is the donor atom, it is called as thiocyaneto. But when nitrogen donates the lone pair of electron, it is called as isothiocyaneto. So again, what we observe here is, it is a single ligand containing two donor groups, that is sulfur and nitrogen, but at a time only one will form the coordinate bonds. Such ligands are called as ambidentate ligands. Here we have ambidentate ligand. Another example, CN, that is cyanide. In case of CN, again we have two donor atoms. One is carbon and one is nitrogen. So when carbon is donating the lone pair of electron and forming a coordinate bond with the metal, in another case nitrogen is forming the coordinate bond with the metal. So when carbon is the donor, it is called as cyano, but when nitrogen is the donor, it is called as isocyano. Moving on to this, here you have the example. Now if you see here, this is the example of ambidentate ligand. We have two donor atoms. The ligands are same. It is NO2 in the first case, and the second case also it is NO2. But in the first case, nitrogen is forming bond with cobalt, the metal. But in the second case, oxygen is forming coordinate bond with the metal, that is cobalt. So what exactly is the definition of ambidentate ligands? A ligand which contains two donor atoms, but only one of them forms a coordinate bond at a time with the central metal atom or ion. It is called as ambidentate ligands. I hope we are very clear with the definition of ambidentate ligands. So in this case, the ambidentate ligand is NO2 minus. In the first case, nitrogen is acting as the lone pair donor, and in the second case, oxygen is acting as a lone pair donor. Here you have another ligand. In this case, we have two donor atoms. One is nitrogen and one is oxygen, and here I have a metal atom. So we have two donor atoms here, and they are binding to a single metal atom, and if you see here, a ring-like structure is formed, and this ring-like structure formed is called as chelate, and the entire property is called as chelation. So what exactly is this word chelate? The word chelate comes from the Greek word chel, which means claws, specifically claws of a lobster. Now, what exactly is the definition of a chelate? Whenever a didentate or a polydentate ligand uses two or more of its donor atom to bind to a single metal ion, then a ring-like structure is formed, and this ring-like structure is called as chelate. The ligands are called as chelating ligands, and the property is called as chelation. The ligands lie around the central atom like the claws of a lobster. So I hope we are clear with what exactly is a chelating ligand. Considering this example here, this example is ethylene diamine tetraacetic acid. So if you see here, it is a hexadentate ligand. That means we have 4 plus 2 donor groups. The first one, if you consider here, we have two oxygen atoms, 1 and 2. In again acetyl, we have 4 donor groups, 1 and 2. So total becomes 4 here. Coming on to this, nitrogen, again a donor group, again another nitrogen is a donor group. So we have 6 coordinate bonds here, and therefore it is your hexadentate ligand. Moving on to ethylene diamine, if you see here, it is forming a bond with one single metal atom, and therefore a ring-like structure is formed which is called as chelate. The ligand is your chelating ligand, and the process is called as chelation. So this is a chelate here. Let us look at the characteristics of chelates. Very important. Chelates defines the stability of a coordination compound. Chelated complexes are always more stable than the non-chelated complexes. So this is called as the chelate effect. What is chelate effect? Whenever you take coordination compounds, the one which are forming chelates are more stable than the one those who are not forming. And also the 5-membered and the 6-membered chelates, they are more stable in nature. That's all for this module. Thank you.